You checked your phone this morning. 70% chance of rain. So you grabbed an umbrella. You didn't know it, but you just made a decision powered by two of the most powerful branches of mathematics ever developed. One of them reads the past, the other predicts the future. And together, they explain almost everything worth explaining. Here's what nobody tells you in school. Statistics and probability aren't just math topics. They're a lens. Put them on, and you start seeing the hidden logic behind a doctor's diagnosis, a stock market crash, a sports coach's lineup decision, and yes, that rain forecast on your phone. Strip them away, and you're guessing. Worse, you're guessing without knowing you're guessing. By the end of this series, you won't just understand these tools, you'll start using them, almost without thinking. The way you already did this morning with that umbrella. But first, what are they, really? Probability is the mathematics of uncertainty. It asks one question: how likely is something to happen? Flip a fair coin. Before it lands, there are two possible outcomes, heads or tails. Neither is certain. Both are equally possible. So the probability of heads is 1 out of 2, or 50%, or 0.5. Same thing, 3 ways of writing it. That's probability in its simplest form, a number between 0 and 1 that measures how confident we should be that a specific outcome will occur. 0 means impossible. 1 means certain. Everything real and interesting lives somewhere in between. Now here's a question that seems simple but isn't. Where does that number come from? How do we actually know a coin is fair? How do we know the chance of rain is 70% and not 60? How do we know a new medication works 8 times out of 10? That's where the second tool comes in. Statistics is the science of learning from data. If probability looks forward, asking what might happen, statistics looks backward. It examines what already happened, finds patterns in it, and uses those patterns to make sense of the world. You flip that coin 10,000 times. You get heads 5,012 times. Statistics says, close enough to 50%. This coin is probably fair. A pharmaceutical company runs a clinical trial. Of 1,000 patients who took the drug, 840 improved. Statistics takes that raw result and asks the harder questions. Is that improvement real or just luck? Is the sample large enough to trust? Could something else have caused it? Is this finding likely to hold up the next time? Statistics is, at its core, how we turn messy, noisy, real-world data into knowledge we can actually act on. The real magic. Here's the beautiful part. Statistics and probability aren't competitors. They're partners. Two halves of the same engine. Think of it this way. Statistics is the detective. It looks at clues, the data, and works backwards to figure out the rules, the pattern, the structure hiding underneath. Probability is the navigator. Once it knows the rules, it uses them to chart a course forward, to make predictions, to quantify risk. The weather model your phone uses didn't just guess 70%. It was trained on decades of atmospheric data, millions of data points about temperature, pressure, humidity. That's statistics building the model. Then the model runs the numbers on today's conditions and outputs a probability. That's probability making the prediction. Same partnership shows up in medicine, in finance, in engineering, in machine learning, in sports analytics. Statistics finds the rules. Probability uses them. One reads the past. The other writes the future. A quick map of what's coming. In this series, we're building both tools from the ground up. You'll start with the core ideas in probability, events, outcomes, randomness, and what that number between 0 and 1 actually means in practice. Then we'll get into statistics, how to collect data that means something, how to summarize it, how to test whether what you're seeing is real or just noise. And then we connect them. Probability distributions, inference, confidence. The moments where the two disciplines lock together and you can genuinely say, I know this, and here's how confident I am. No prerequisites, concrete examples at every step. Each chapter ends exactly where the next one picks up. There's a problem at the heart of probability that has tripped up mathematicians, gamblers, doctors, and judges for centuries. It's called the base rate fallacy, and it goes like this. A test for a rare disease is 99% accurate. You test positive. What are the chances you actually have the disease? Most people say 99%. The real answer is almost certainly below 50%. That gap between what feels right and what the math actually says is exactly what this series is about. Next chapter, we crack that problem open, and once you see it, you'll never read a statistic the same way again.